Good afternoon, Math Foundations people. So this will be day 7 in our graphing units, and we've kind of went through all the quadratic regression, linear regression, all that kind of stuff with the graphs and the shapes of the polynomial curves. So that was the first part of our area. The second part is to look at the sinusoidal curves, sine and cosine curves. Okay, and we're going to start off by looking at degrees and radians first today. And so that's where we're getting into the second part of our unit here. Okay. And I'll just open up the blackboard here. And what we're going to be looking at is how we convert manually from degrees into radians, what radians are, and how we convert from radians back to degrees today. Okay, so I'm just going to wait for the board to pop open here, and we'll go through what our outline is for today. There we go. Okay, let's set up. Okay, the last thing we did was hand-drawn linear graphs, which is something that you last saw in grade 10, or you might have saw a little bit in grade 11, who knows. So this, depending on which course you took, this is day 7 in unit 4. And what we're going to look at today is called, we're going to be looking at radians, radian measure, and degrees. Okay, so we're going to be looking at converting back and forth between them. And we're going to be looking at also using the radian formula. And we'll do some examples of both of those areas. Okay, if you took pre-cal 20 already, you probably know how to do this, which is good if you did. If you didn't, that's okay, because we're going to do it here. Okay, so let's take a look at what we talk about with radians. So we'll start off with radian measure. Okay, so radian measure is a measure of an angle in a circle. So if we have a circle of some particular radius, so we'll draw a circle here. Okay, so where's my shape thing? There it is. So get a little dot there for our center. We draw a bit of a circle there. Okay, and along here, if we subtend 2 radii, so I will just use straight lines here. Okay, there and there. If we do that, well, maybe we should do that in a different color. Let's do that line in a different color so that we can see the difference. This kind of gross looking green. Okay, there's that line there, and there's that line there. So as we look at that, this particular, I'll take my marker out here. Okay, and we'll just get it labeler here. Okay, if we call this the radius, okay, this is the angle measure, and it subtends some arc here. So we got to kind of draw on that. So this is called our arc here, the outside of the circle here. Okay, and we use that arc. Okay, and the symbol we use for arc, or that we're going to use, is S. And the symbol that we're going to use for radius is a small r. And this is going to be the angle measured in radians. Okay, so that's the theta represents the angle measured in radians. So the formula that we have is that radians equals, so theta, the angle in radians, equals the length of the arc divided by the radius, the length of the radius. This is the length of the arc. Of course, you have to have the same unit. Okay, and this is the length of the radius. Okay, and here we'll have our angle measurement in degrees. Or sorry, in radians, not degrees, pardon me. Okay, and the symbol sometimes is just called rads. Okay, so that's kind of how that formula works. So, for example, if we're going to use a simple formula with a circle in it, just wait. I'm trying to find a good one. There's a good one right there. Okay, so let's say we had. Let's move this down a little bit so we can see it a little better. Let's do an example here. Let's draw another circle. Say we have this circle here. Let's say that we have a line like this and like this. And we say that for that, we're going to say that theta equals, let's say that this theta is, I don't know, that's probably about 2.6 radians. Find S when the radius is, let's say, 10 centimeters. Okay, so we take the formula. Radians equals arc length divided by radius. Okay, we want to find S, so we have to multiply both sides by R. So R would then be equal to R times theta would be, sorry, not R. We're not trying to solve for R. We're trying to solve for S. So to isolate S, we have to multiply this side by R. Oops, I erased it there. So multiply this side by R to get rid of it. Multiply that side by R. So R times theta is equal to S. So if we take our radians and multiply it by our radius, we should get the arc length. So this would be the R value was 10 centimeters times the radians of 2.6 radians, which we'll call rads, and that gives us 26 centimeters for our arc length. Okay, the radians are just an angle measure in there. Okay. Okay. The other relationship that we need to know is degrees. Now we know that in a circle, if we take a circle and we do a whole round around it, it's the circumference of the circle. If we know what the circumference of the circle is for a radius of 1, we can figure out how many radians there are in one circle. Okay, so you remember that the circumference of a circle is 2 pi r, 2 pi times r, so that if we say that our radius is 1, that means 2 pi times 1, that means there's 2 pi radians, right? 2 pi radians if we put 1 for r. So if we imagine this whole circle and that the radius is only 1, and we know that the circumference of any circle is 2 pi r, And if r is 1, then this would be 2 pi. Then our radian measure is going to be 2 pi divided by 1, which is 2 pi radians. So therefore, we know in terms, let's put a little title here, say the relationship between radians and degrees. That's what we're getting into now. And we're looking at, we know that there are 2 pi radians in every circle. We also know that there are 360 degrees in every circle. So we can equate both of these and kind of come up with a relationship. So we know that 2 pi is radians. Equals 360 degrees. Well, we know that we can divide both by 2 pi and get out how many radians or how many degrees are in 1 radian, but it's kind of easy just to divide the 2 out. We can say that we know that there are pi radians is equal to 180 degrees. And there's our relationship. Pi radians equals 180 degrees. Okay, so then we can look at converting back and forth from radians to degrees and from degrees to radians. So let's take a look at using this relationship that pi radians equals 180 degrees. Now, if you wanted to, you could figure out how many degrees 1 radian is dividing by pi, and we know what pi is. It's approximately 3.14, or approximately 22/7 is a good approximation of it, but not quite. Okay, so let's take a look at a couple of converting questions with radians here. Okay, so let me get myself set up here. That was a couple examples. Okay, so the first thing what we're going to do is we're going to use this relationship here to convert radians to degrees. Okay, so the first example that we're going to look at is converting radians to degrees. Okay, so we're going to be going, so this is where we're going to use ratios. Okay, so if we go, we're going to be going, so what we can do is we can write this as a fraction. We can say that our relationship is pi radians over 180 degrees. So we're going to put the radians on top over the degrees on the bottom. Could be the other way around if you want, it doesn't matter, but just make sure you do it. That's how we're going to do this. Okay, so that's going to be our relationship that we know. So this is method 1, using ratio. Okay, so convert, let's say, I don't know, 8.5 rads into degrees. Okay, so we're going to do that here. So what we'll do is we'll set up the ratio. It's pretty simple. Just got to use ratio. So we'll do the ratio pi radians over 180 degrees. So this is rads, and this is degrees. And that's going to be, now we're trying to find degrees, so we are given 8.5 rads. And we're going to get X amount of degrees. Okay? So we can just cross multiply. Okay, so we can say 180 degrees times 8.5 rads is equal to pi radians x. Okay, so you can do some calculator work here. So we'll move that up so we can see it a little better. Okay, so if we do it this way, 180 times 8.5 gives us 1530 degree rads. Equals pi rads x. Okay, so then now when we get to here, we got to divide both sides by pi to get x by itself. And that's going to eliminate the radians on both sides. Right, and we're going to be left with 1530 degrees over pi, because we'll cancel out the radians, is equal to x. So we got to take 1530 and divide it by pi. Okay, or 3.14 if you do approximation. I use my calculator's pi button. And then we'll round it off. So it's going to be about 487 degrees. Okay, that's the ratio method. We use that quite a bit. Okay, method 2 is if you look at this ratio of pi over 180, you could, pi rads is smaller, or you could do 180 degrees divided by pi radians. So method 2, we know, knowing that 180 degrees is pi radians. So if we divide that out, this equals 57.3 degrees per radian. Okay, so that's the relationship there. So you could also do it, it's method 2, multiplication or division, depending on which way you're going, if you're going forward or backwards. So you could say, well, since we have 8.5 radians, and we know that 57.3 degrees per radian times 57.3 degrees per radian, we're going to get the number of degrees. So it should give us about the same thing. 8.5 times 57.3, so that's 487 degrees. Okay, so there's 2 ways you can do that converting. Okay, the other thing that we can do is we can convert from degrees into radians. Okay, so the first one we did was converting the degrees or radians to degrees. This time we're going to go from degrees to radians. Okay, the same thing is here. We're going to use the ratio or the fact that 57.3 degrees is 1 radian. So this one is converting from radians, from degrees to radians. Okay, so let's say, how many radians are in 400, well, we did 400, let's say 235 degrees. Okay, so we can do ratio again. Which is the way I like to do it. So we know that pi radians is the same thing as 180 degrees. So if we set up a ratio, we know the degrees. or 235 degrees, how many radians are we going to get? Okay, so this, if we do the cross multiplication, 180 degrees x equals pi radians times 235 degrees. Okay, so get x by itself, we can multiply this out. Okay, so use the pi button, 235 pi. So my calculator likes to do that, so I just convert it. If you want a decimal, you can just convert it. So it's going to give us 738.3. Okay, and this is rad degrees. So the degrees are going to cancel out this time. When we divide by 180, 738.3 divided by 180, we're going to be left with degrees. So I just leave that on my calculator and I type in divide by 180, and I get 4.1 radians. Sorry, this is rads because we canceled the degrees out. Sorry about that. This is 4.1 radians. Okay, and that's an example of how we convert. Now, you could use the other method as well. So we know that we have so many degrees. What was it, 235? Why am I putting a 4 down? Method 2. Okay, we know that 57.3 degrees per radian. So if we have 235 degrees, this time we're going to we've got 57, we're going to have to divide by 57.3 degrees per radian. Now, how do I know to divide in this case? Well, I know that there are going to be less radians than degrees. If you think of a circle having 360 degrees in it and a radian only having 2 pi, which is 6.28, if you kind of roughly guess 2 pi's, 3.14 plus another 3.14 would be 6.28. So we know that radians are bigger. So that means if radians are bigger, there's going to be less of them than 235. So that's how we know we're dividing by 57.3 degrees per radian. So if, for example, we had exactly 57.3, we'd know we'd have 1 radian. We have a little bit more than that, and that's what we get. So if we take our 235 and divide it by 57.3, we're going to get our 4.1 again radians. Okay, now the other thing that they might do is they might combine the formula of radians with type question with an example of converting as well. So they might do the two things together. So let's check our time here. I didn't put my preview up, sorry. We do that here. Okay, so we're good. We're about 24 minutes in. So enough time to do an example like this. So sometimes they will give you a circle question and they'll say something like this. Let's type one out here. Let's say a circle has an arc, or an angle, sorry, let's do it properly. An angle in a circle has an arc length of 58 centimeters and a radius of 25 centimeters. Find the measure of the angle in degrees. We're going to have to use the formula to find the angle in radians and then convert it to degrees. That's our strategy. So we're going to end up going like, we're going to have to use the formula to find theta, and then we're going to convert theta into degrees. Sorry, I forgot. Convert Okay, so it looks something like this. So the first thing we have to do, okay, we know that theta is equal to S over R, little r, pardon me. So we've got an S of 58 centimeters divided by 25 centimeters. And this is going to give us a value in radians, not in degrees. So we have 58 divided by 25. So we get 2.32 radians. Now you can choose which way you want to go. You can use the 57.3 degrees per radian. And since we're converting it into degrees, we're going to have way more degrees than radians. So we know that it's going to be multiplication, or we can do ratio. So let's convert. Okay, so if we convert now, pi radians over 180 degrees, I'm going to do it this way. That's equal to 2.32 radians over x degrees. Okay, the radians are going to cancel out and we're going to be left with degrees. So if I cross multiply here, I've got 2.32 times 180 equaling pi x. Okay, so 2.32 times 180. That's 417.6. And then divide both sides by pi. So, and to the nearest degree, I get 133 degrees. Okay, so there's an example of that. Okay, so there's the three main type of problems: converting one way or the other, or using the formula, and sometimes they'll blend them together as well. So we'll do a couple practices in this area. So let me just pause the video here and dig up some practice questions for you, and then I'll put them up. Okay, so here we can do on page 520, 519, 520. Now they use the word estimate, and the reason they're using estimate is because it's not an exact value. You're rounding the pi off, or you're when you're multiplying, or you're multiplying by 57.3, or dividing by 57.3. So when you're doing the questions where it says estimate, they're actually saying find out. Okay, they mean use the ratio predictor, or use the 57.3 degrees per radian to help yourself figure out what it is. So you can do number 4, 5, 6, and 8 for some practice. Okay, and then next day we're going to get into, now that we know radians, we're going to talk about sine function, cosine function. Okay, and that's the next thing that we'll look at. Okay, we'll see you tomorrow.